Hi everyone, welcome back to Useful Genetics. This is Lecture 3H, where we're going to talk about regulation of protein activity. That is how the cell controls what the proteins do after they've been synthesized. And basically, protein activity can be regulated by other proteins, it can be regulated by small molecules, and it can also be regulated by other processes. We'll talk about voltage gating. So, first a schematic example. Here I've diagrammed the same catalytic domain and substrate that I used earlier to illustrate catalysis. But this time I'm going to use it to illustrate a kind of regulation. I've drawn in, now our catalytic domain has a second domain, another part of the protein that's a regulatory part of the protein, and this also has a binding site. But this isn't a catalytic site, this is a regulatory site. It's a site where a regulatory molecule can bind. The regulatory molecule may be a complex protein, or it may be a small molecule. It could even be the normal product of the reaction. So let's go back and do that again. So the regulatory protein can bind, the regulatory molecule can bind to the domain, changing the conformation of the catalytic part of the protein. The active site has now closed, so the substrate's not able to bind and no catalysis can happen. This kind of inhibition can happen in response to various cellular changes. One particularly common kind is where the inhibitory regulator is actually the product of the reaction. It's the molecule the substrate is normally converted into. When the cell already has plenty of product, it doesn't want any more. The product serves as an inhibitor, shuts the enzyme off, so no more product is made. Now, here's another example of regulation. This is phenylalanine hydroxylase, which we talked about a few lectures ago as an example of a catalytic protein. Phenylalanine hydroxylase acts on phenylalanine, the amino acid, breaking it down to tyrosine. But if too much phenylalanine accumulates in the cell, phenylalanine will instead be converted to the toxic molecule phenylpyruvate. In cells in infants that have a mutation blocking the activity of phenylalanine hydroxylase, we get the disease phenylketonuria caused by the toxicity of this product. But even normal cells have ways to make sure that phenylalanine levels never get too high. And that's the function of the regulatory domain of the enzyme. What the regulatory domain does is it binds phenylalanine when phenylalanine concentrations are high. It doesn't bind it when it's low, but when it's high, the regulatory domain senses the concentration, the high concentration, and it basically kicks the catalytic domain into high gear so that the phenylalanine hydroxylase becomes much more active when there's too much phenylalanine in its environment, which makes sense because phenylalanine can otherwise lead to a toxic product. Finally, here's another protein that we saw earlier. This is the voltage-gated sodium channel that functions in our nervous system. Here, just to remind you, this is the membrane, and we've got two versions of the protein shown. In one version, the protein channel is closed. No sodium ions can pass through it. In the other version, the channel is open. Sodium ions can pass from whichever side the concentration is high to a side where the concentration is lower. Now, this protein, this membrane transport protein, is gated by voltage. It senses, in addition to providing a channel for transport that can open and close, it has sensory subunits, that's these beta subunits here, which sense the voltage across the membrane, the difference in charge between the two sides of the membrane. And when that difference reaches a particularly high level, that triggers the channel to open, allowing the sodium ions to move from one side to the other. This has the effect of changing the voltage difference across the membrane. Once they've moved across, the voltage difference has dropped, the channel closes. Other cellular processes then regenerate the voltage across the membrane, triggering the channel to open again. This is how nerve impulses work, and its regulatory effects changing the conformation of the channel that lets the ions cross the membrane. So what we've done, we've considered 3 examples of the regulation of protein activity. The first was a schematic diagram where an inhibitory small molecule, which could, for instance, be the product of the reaction, turns the reaction off. The second was a real example, phenylalanine hydroxylase, where high levels of the substrate of the reaction turn the reaction up. They activate catalysis to a higher level. And the third was not a catalytic effect, but the opening and closing of a channel in responses to change in the voltage across a membrane. Now, coming up next is the third of our regulatory examples. We're going to talk about regulation by RNA. I hope to see you there.